Maybe the most badass political war crime ever committed was in Season 6, Episode 7 of Game of Thrones, when Cersei orders the largest cache of Wildfire in Westeros, which is conveniently located under the Great Sept of Baelor, to be detonated, killing and vaporizing the bodies of those inside, destroying the Sept, and leveling half the city within a mile radius. You know, there's something crazy attractive about doing the physics to find the total blast yield of Wildfire. So a warning in advance, but this video is going to be a physics exam writer's wet dream since it clocks in at about 90% assumptions. But that's physics. First we have to find out how much the Wildfire destroyed, more specifically the volume of material used to build the buildings. Let's start with the Great Sept itself. It's roughly made of 9 different shapes, 1 hollow heptagonal prism, 1 hollow dome, and 7 cylinders for the towers. Plugging all these values in and adding all the volumes together, we get a total of 63,000 cubic meters of building material. But the explosion also vaporized the people inside. We don't get a good view of everyone, but I count about 55 people in one corner times 7 corners plus the 7 septums in the middle gives us 392 people that are no longer solid. Now let's focus on the half-leveled city outside. King's Landing is filmed in Dubrovnik, Croatia, so let's assume it has a similar population density of 2,000 people per square kilometer. Since the affected area is a square mile, this gives us 5,180 half-vaporized people and their half-destroyed homes. At 5 people per house, we get a total of 1,036 damaged houses. The people here live in the expensive downtown area, with a comfortable 100 square meter floor plan, 3 meters of headroom, 4-inch thick walls, and at only 3,345 golden dragons a month and making a 20,000 dragon down payment. This is canon, trust me. Anyway, this gives 22,605 cubic meters of building material. Cut those in half and adding them to the people and the material of the Great Sept, we get 2,982 vaporized people and almost 74,500 cubic meters of building material. Before we find the blast yield needed to cause as much damage, we need to find out how much Wildfire was actually detonated. Well, when Lancel gets surprise shanked by a kid, we get a glimpse of how many barrels of Wildfire are down there, and we'll assume Lancey is in the center of the room. On one half of one wall, we see maybe 7 shelves containing 12 barrels each, times 2 for the other side of the wall, times 2 again for the other side of the hall, gives us 336 barrels. A barrel is considered to be 42 US gallons, meaning there's 53.4 cubic meters of Wildfire. To find the density of Wildfire, I just averaged the densities of a few IA classified liquids, which is just a fancy way of saying this shit will explode if you're an idiot. With a density of 665.5 kilograms per cubic meters, we have a total of 35,550 kilograms of Wildfire. Alright, now we can find its blast yield. Let's start easy. 2,982 people times 2.99 gigajoules gives us 8,916 gigajoules. Check out my Dragonfire video to find out where that number comes from. Alright, not bad. Now for the buildings. Most of the buildings we see look to be made out of some kind of sandstone or limestone. Dubrovnik is paved in limestone in real life, so let's say the buildings in King's Landing are also limestone. The best model we currently have for blast yields is the Kuznetsov equation of the Kut-Ram fragmentation model, where X is the average particle size, which we will be assuming to be 30 centimeters. A is the rock factor, which is about 7 for limestone. K is the Wildfire mass to rock volume ratio. Q is the mass of explosives used in kilograms, and RWS is the relative weight strength of the explosive. RWS of 100 is equal to ANFO, a popular blasting powder used today, and TNT has an RWS of 115. Plugging in all the numbers and solving for the RWS, we get 463, about 4 times stronger than TNT. That's pretty realistic. Rearranging the Coot-Ram equation and using TNT's RWS and the same destruction values, we get an equivalent of 158 tons of TNT to do similar damage. Since 1 ton of TNT gives off 4.2 gigajoules of energy, it would take about 661 gigajoules of energy to destroy the buildings. Plus the energy from vaping the people, and the wildfire has a total blast yield of 9.58 terajoules, about 15% that of the bomb dropped on Hiroshima, but in the Middle Ages, and without that pesky radiation. All in all, pretty decent physics. Good on you, Georgie.